Greetings to all. Welcome to the e-mobility. We are starting up our new course. So we'll be teaching you power electrons converters for EVs. So why we have picked up this course? Because most of the students were concerned that they want to learn the power electronics behind the EV converters. So for this, we have designed this course, power electrons converters, and we'll be using MATLAB Simulink as a software. So this course will be consist of 5 modules. Introduction to Simulink will be first, and the power electronic basics. The second module will be covering the DC-DC converters which are being used in the EV application, like buck boost converter or the flyback converter or the DAB or dual active bridge. In module 3, we'll be covering inverters, or the inverters you can also say DC to AC converters, and AC conversion for EV motors. So we'll be covering about all the types of inverters and the popular inverter and inverter schemes which are SVPWM. All the PWM techniques will be also be covering in this module 3. In module 4, we'll be covering battery management system and the power electronics behind that. So a basic of BMS, we have already made a video and course also. So in this module 4, we'll be focusing only on the power electronic side of the BMS. And lastly, the advanced topic. So we'll be going through some of the advanced topic like wireless transmission, or wireless chargers. So these are the all topics we'll be covering. So let's see what each module will be consisting of. So module 1, as we have already talked about, is an introduction to MATLAB Simulink and power electronics basics. So this will cover overview of the Simulink environment, which you people might be knowing, but we'll be covering it. Understanding semiconductor devices like diode, MOSFET with the use of MATLAB. Obviously, we are using MATLAB for teaching purpose. For each and every theory class will be combined with some practical application using MATLAB Simulink. Then basics of voltage current sources in Simulink, modeling our passive components. So we'll be making a simple circuit and we'll be testing it. And lastly, we'll be setting up a basic Simulink environment. So how a basic Simulink environment can be set up, and this includes like how to set up a solver, how to set up on what solver setting should be there, and how to debug error whenever it is coming while running the program. And lastly, there is a project in each and every module. So in this module, we'll be understanding Simulink environment and we'll be doing a basic of some circuit. Then the next module is a DC-DC converters. So for DC-DC converters, for EV application, we'll be focusing on theory of DC-DC converter like buck boost converter, and also one converter we'll be considering is DAB, which is very frequently used for bidirectional charging. Then simulating a buck converter in MATLAB, we'll be doing it. Then simulating a boost converter in MATLAB. So you can see this module 2 is all about the practical application of the buck boost implementation. So designing a bidirectional converter. This bidirectional converter is nothing but a DAB. We'll be considering it. And then efficiency analysis of the DC to DC converters. Lastly, a design and simulation of bidirectional converter will be considered to handle regenerative braking. So this DAB converter will be taken as further, and we'll be in detail designing this DAB converter from control side to the main circuit side. So the complete project will comprise of the bidirectional DC-DC converter. The third module is the inverter and the AC conversion for EV motors. So video 1 consists of introduction to inverters, which is single phase, 3-phase. Obviously, we'll be focusing more on the 3-phase side. Then simulating single phase inverter in MATLAB Simulink. Then simulating a 3-phase inverter in the MATLAB Simulink, and harmonic analysis and the minimization technique. And then the control strategy, which I was talking about, that will be focusing on SPWM and third harmonic injector SPWM, which is equivalent to SVPWM. So those of you who have heard about these things will get it, that what are these techniques. So we'll be covering these two techniques. And lastly, we'll be developing a project of 3-phase inverter drive. So mainly either we will be using PMSN or we will using induction motor. So any of the drive we will be using, and using this inverter model will be driving that motor. Then the fourth module consists of the battery management system. So what are the battery management system basics we'll be going through, what is BMS, then how to model a battery pack, and then designing a charging discharging circuit, and bidirectional power flow control for the EVs. Obviously for bidirectional we'll be using that bidirectional converter, and integrating BMS with the vehicle power electronics. So again here, based on these 4 or 5 videos, we'll be doing a one project. We'll be simulating a battery charging and discharging system with bidirectional power flow. The last topic is the advanced topic in the integration. So this topic consists of wireless power transfer, how to get a grid connected. So this is all we will be covering, and uh, most of this is a theoretical part, because for the advanced topic we will be doing a small project on wireless power transfer, but these advanced topic will be limited to the theory part only. So design and simulate of the wireless power transfer for EV battery charging. So this is all about the course. So there are total of 5 modules which we have seen, and we'll be updating weekly 2 videos for related to this module. So the first module we'll be covering is the module 1, and we'll be uploading these 2 videos in the coming week. So thank you for staying.